Hello students, so yesterday we have seen the problems on last sample test for single mean here. But when we consider the two different samples of size n1, n2, definitely the sample size n1 and n2 are greater than 30. Then also we need to test the difference of means here. So let us move to the problems. Samples of students were drawn from two universities A and B, and from their weights in kilograms, their mean and standard deviation are calculated and shown in a tabular form. So make a last sample test to test the significance of difference between the means. So the question is very direct here, right? So we have to test the significance of difference between the means. So if you see the data here, we have two universities and the mean weight of the students are 55 kgs and 57 kgs, and the deviation in their weights are 10 kgs and 15 kgs, and the size of the sample they have considered as 400 and 100. Now first we have to frame the alternative and null hypothesis here. So as usual here, null hypothesis means it is an unbiased statement which shows no difference between the things considered. So mu A is equal to mu B. That means there is no significant difference between the weights of the two universities, right? Between the students' weights of the two universities here. Then against H1, the alternative hypothesis. So here we have no comparable words in the question. So just they are asking you to test the significance of difference between the means. So when there are no comparable words, then here the alternative hypothesis is always two-tailed, that is mu A not equal to mu B here. Then under the null hypothesis, means under this H0, the test statistic is given as Z equal to here x bar A minus x bar B by square root of sigma A square by n1 plus sigma B square by n2 follows a normal distribution with mean 0 and variance 1 here. So here actually the test statistic formula is x1 bar minus x2 bar by square root of sigma 1 square by n1 plus sigma 2 square by n2. But here in our problem we have considered two universities as A and B. So that's when the test statistic also I have considered x bar A minus x bar B by square root of sigma A square by n1 plus sigma B square by n2 here. Okay. Now if you move on to the given data here, n1 is 400 and n2 is 100. Now x bar A is given as here 55 and x bar B is given as 57, and sigma 1 is given as 10, which implies sigma 1 square is 100, and sigma 2 is given as 15, which implies sigma 2 square is 225. Now substitute in the Z statistic. So x bar A minus x bar B means 55 minus 57 by square root of sigma 1 square by n1, that is 100, by n1 is here 400 plus sigma b square means 225 by here n2 is 100. Now we have to simplify this. So the z value will be, in the numerator it is minus 2 by, now square root of, first we have to simplify this part. So 100 by 400 plus 225 by 100, right? Then square root of that will give you the answer 1.5811. So minus 2 by 1.5811. So first we have to simplify the sigma 1 square by n1 plus sigma 2 square by n2. Then you have to press the square root of that, right? Then you will get 1.5811. Now z can you will get in terms of negative, because here in the numerator we have negative. So 2 by 1.5811 gives you minus 1.2649. Now whenever the z calculated value is negative, we can consider the modulus of that. So mod z cal is 1.2649. Now The tabulated value of Z at level of significance is not mentioned for this question. So whenever nothing is mentioned about the level of significance, we have to consider it as 5%. So Z tab at the 5% level of significance for the two-tiled. Here the alternative hypothesis is not equal to. So for two-tiled is given by 1.96. That means Z tab is 1.96 here. Now mod Z cat is here 1.26. So mod Z cat is less than Z tab. So therefore H naught is accepted. H naught is accepted means here there is no significant difference between the mean weights of the students of two universities. That means here mu A is equal to mu. So this is the conclusion of the problem. So first you have to simplify this part, then you have to find the square root of that, then obtain the test statistic. So in this way we have to solve the difference per means of last samples. Now let us see the next problem. A simple sample of height of 6,400 Englishmen has a mean of 67.85 inches and a standard deviation of 2.56 inches. While a sample of heights of 1,600 Australians has a mean of 68.55 inches and a standard deviation of 2.52 inches. So do the data indicates that Australians are on the average taller than Englishmen, and use the level of significance as 0.01. Now here the question is very clear what we have to test. That is, do the data indicates that Australians are on the average taller than. Means average is mentioned, so it is a test for difference of means since we have two samples here. So before defining the null hypothesis, let us consider mu1 as the average height of here Australians. mu1 is here average height of Englishmen. And mu2 represents the average height of Australians. Now, the null hypothesis is always unbiased. So, mu1 is equal to mu2. That means there is no significant difference in the average heights of Englishmen and Australians. Then, against H1. So, do the data indicates that Australians are taller than Englishmen. But here, mu1 represents the average height of Englishmen and mu2 represents the average height of Australians. So, mu1 is less than mu2. Then, under the null hypothesis, the test statistic is given as z equal to here x1 bar minus x2 bar by square root of sigma 1 square by n1 plus sigma 2 square by n2 follows a normal distribution with mean 0 and variance 1 here. Now, if you write the given data, N1 means the sample size of Englishmen, that is 6,400, and N2 is the sample size of Australians, that is here 1,600. Now the mean height of the Englishmen are, that means x1 bar is 67.85 and the mean height of the Englishman is here 68.55. Then sigma 1 means the standard deviation of the Englishman is 2.56 and the standard deviation of the Australians is here 2.52. Now substitute these values in the Z formula. So x1 bar means 67.85 minus 68.55 by square root of here sigma 1 square means 2.56 square by 6,400 plus 2.52 square by 1,600. Now let us first simplify the numerator here. So 67.85 minus 68.55 is minus 0.7. Now coming to the denominator, so 2.56 square divided by 6,400 plus 2.52 square divided by 1600. But under the square root, it is here 0.0707. Now this is equal to here 0.7 divided by 0.0707 is 9.9010. That means minus 9.9010. Now our Z cal is here negative. But our alternative hypothesis is here left time. So we can't consider the modulus of that. So next, obtain the tabulated value of Z at the level of significance they have mentioned as 1%. So at 1% level of significance for one tilde. So why we are mentioning here one tilde means for the alternative hypothesis is one tilde means here the before the tabulated value we have to place a minus sign here. So the tab value will become here minus 2.33. So that means Z calculated value is less than Z tabulated value because the cal value is minus 9.9010 and the tabulated value is here minus 2.33. So Z calculated is less than Z tabulated. So that means H0 is rejected. H0 is rejected means here this we are accepting the H1 that is mu1 less than mu2. So what they asked you to test, do the data indicates that Australians are on the average taller than Englishmen. So that's what we are accepting here, that is mu1 less than mu2. So I hope you understand this problem. See the last problem on difference of means. So the average marks scored by 32 boys with a standard deviation of 8. And while there for 36 girls is 70 with a standard deviation of 6. So does this indicate that the boys perform better than girls at 5% level of significance? Now here in the question, it is just given that does this indicate that boys perform better than girls? So the performance of the student can be assessed by the average mark, right? So here indirectly they are asking you to test the difference between the means here. So first we consider that mu1 represents the average performance of boys. So you can consider average marks scored by boys or average performance, right? Then mu2 represents the average marks scored by girls or average performance of girls here. Then obviously the null hypothesis will be mu1 equal to mu2. Means there is no significant difference between the average marks of boys and girls. Then again as to H1, here in the question we have a comparison that boys perform better than girls. So better than is a comparable word here. So that means mu1 is greater than mu2. The average performance of boys is better than girls here. Then under H0, the test statistic is Z equal to x1 bar minus x2 bar by square root of sigma 1 square by n1 plus sigma 2 square by n2 follows a normal distribution with mean 0 and variance 1. Now, if you see the given data, the number of boys are here 32 and the number of girls are here 36. Now the average marks of boys is 72, that is x1 bar, and the average marks of girls is here 70. Now the standard deviation between the marks of boys is 8. Sigma 1 is 8, which implies sigma 1 square is 64, and sigma 2, the standard deviation of marks for girls is here 6. So that means sigma 2 6 means sigma 2 square is 36. Now substitute in the Z formula. So Z equal to 72 minus 70 by square root of here 64 by 32 and 36 by 36. Okay. So 72 minus 2 is here 2, the numerator is 2 only. But 64 by 32 means 2 and 36 by 36 means 1. So 2 plus 1 is 3 and root 3 is 1.732. So Z equal to 2 by 1.732. It is here 1.1547. So Z cal is 1.1547 here. Now we have to obtain the tabulated value of Z. At here they are asking you to test at 5%. So Z tab at 5% level of significance for the corresponding alternative is here greater than symbol, right tile. That means here one tile. So 5% one tile value is here 1.645. So Z tab is 1.645 and Z cal is 1.1547. That means Z cal is less than Z tab. So H0 is accepted. H0 is accepted means here there is no significant difference between the average marks of boys and girls here. So that means mu1 equal to mu2. So we are rejecting the alternative hypothesis. That means the average performance of boys are better than girls is rejected here. So the final conclusion is here H0 is accepted means there is no significant difference between the average marks of boys and girls. They are equal. With this, we have completed the last sample test for difference of means.